These are the practice problems for Lesson 8. Remember that Lesson 8 was on rotation patterns. And it's mostly rotations of 180 degrees, which is this problem has to do with 180 degrees, and also rotations of 90 degrees. And so we'll look at that in a moment. So for this first problem, what happens when you rotate this line segment 180 degrees around different centers of rotation? In the first case, the center of rotation is D. So if you rotate this line segment around D 180 degrees, it's going to map. That means it's going to land. When you use the word map, it means where is it going to go to? Where is it going to map to? And it's going to map to the position that's just opposite this line segment in the beginning. So it's just going to flip over here and extend this line segment out this way. So it maps there. It's this pink line, and point M rotates around 180 degrees and is still in the center here, and point C rotates all the way around and ends up way down here. The second one, the center of rotation now is E, and remember that the center of rotation for 180 degrees is the midpoint between a line that connects the two corresponding points. So if I draw C, this line segment C to E, and then just extend it through, I'm going to end up where C maps to when it rotates. If I extend M through the other side, I'm going to end up right about here, where M rotates to the other side, and D likewise the same thing. And so if I extend those line segments through, remember that the center of rotation is the midpoint between a line that connects the two corresponding points. So C to C, the midpoint is E. M to M, the midpoint is E. And D to D, the midpoint is E. And the last one, if the center of rotation is M, C just flips over to here where D is, and D just flips back over to where C is. You connect those two corresponding points. The midpoint is this center of rotation, which is M. The other thing that I want you to see is that in 180 degrees rotation, wherever that center of rotation is, the line segment always maps to a line that is parallel to the original line segment. So all three of these are parallel to that original line. So for 180 degree rotations, change the center of rotation, you end up with parallel lines, these pink lines. And the center of rotation is the midpoint between the corresponding points. So these are the corresponding points. Center of rotation is the midpoint. Corresponding points, the center of rotation is the midpoint. And the corresponding points, M to M, the center of rotation is the midpoint between them. C to C, the center of rotation is D, the midpoint between them. All right, problem number 2. What happens now with 90 degree rotations in this triangle? So rotate this 90 degrees this way. So that's clockwise. The center of rotation is A. So C is going to go over here to this point right here. If you connect those two corresponding points and draw a line that's perpendicular to this line segment at the midpoint, you're going to end up at the center of rotation, which is right here. I didn't write that out for you, but it's a way to find the center of rotation for a 90 degree, actually any degrees rotation. B ends up here. So if I connected these 2 points and I drew a line that's perpendicular, actually it'd be this line right here, that's perpendicular at that midpoint to this line segment, it's going to intersect right here at the center of rotation. So this pink triangle is going to rotate now to the red triangle, or triangle ABC. This is now a 180 degree rotation. So once again, we're at the spot where if you connect the corresponding points, the center of rotation is the midpoint. Connect the corresponding points, B to its corresponding point right here. The center of rotation is the midpoint. This blue triangle is a 270 degree rotation, so all the way around here. And so here's all 3 rotations. The pink is the 90-degree rotation, the red is the 180-degree rotation, and the blue is 270 degrees rotation. All right, so now we're supposed to describe a sequence of transformations that moves A, B, C, D to its prime values, A prime, B prime, C prime, D prime. And so if you look long enough, you can see, first of all, it's a translation. So translate 1, 2, 3, 4 over, and 1 down, it looks like. Translate 1 down. And once you get it in that spot, you can see that it's a reflection over this line of reflection, which is this line segment D prime, C prime. So reflect it over. So you have to draw arrows that are perpendicular to show you where this point goes over the line of reflection perpendicular to the line of reflection, forming a right angle. It flips over right there and ends up at that blue quadrilateral. This problem, same idea, sequence of translations, but instead of translating and reflecting, we're going to translate and then rotate. So we're going to translate this over, translate it up, so it's over 4, 1, 2, 3, 4, and up 1. So now we're going to rotate it around point B. And so notice that it's a 90-degree rotation. So this is the rotation this way. This is 90 degrees from here going this way up to here. And so if I count, I'm going to count this way. This is 1 unit, and then up 3. 1, 2, 3. And now if I switch axis, so I rotate this around 90 degrees, I count 1 and 1, 2, 3. I'm going to look at that, how that's changing the coordinates in just a moment. You're actually reversing the coordinates, and you're changing one of the signs. So if I look at, this is C. So 1, 2, 3, 1, 2. Now I'm going to rotate this 90 degrees, and I'm going to count out 1, 2, 3, 1, 2. And I must have skipped D. Oh, this first one was A. I'm sorry, this first one was A. So 1, 2, 3, 1. And then 1, 2, 3, 1. So that's A. D, 1 over, 3 up, 1, 2, 3. 1 up, 3 over, 1, 2, 3. And then finally C. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. And so this is the 90-degree rotation of A. Goes from here, and it ends up rotating over to here. 90-degree rotation of D, and a 90-degree rotation of C. So if you look at the points, if you just treat B as 0, 0. So now for A, I'm going to count -3. So 1, 2, 3, and then +1. So I end up at A right here. And so from this point, I'm calling it 0, 0 now. If I just reverse the coordinates, I'm going to count along the x-axis 1 unit. And then now I'm going to count along the y-axis 3 units. 1, 2, 3. So notice I'm reversing the coordinates. -3, 1. And I'm reversing them to 1, 3. And I'm also changing the sign of this 3. Instead of along the x-axis, it was -3, 1, 2, 3. It's kind of hard to see. And then along the y-axis, it's a +3, 1, 2, 3. For D, it's -1, +3. So -1, +3. And then that switches to a +3, 1, 2, 3, and a +1 up here. So here was a -1, +3, and here it's a +3, +1. So it reverses the order, and one of them switches signs. And for C, reverses the order, so it's 2, 3, and now it becomes 3, 2, but one of them switches signs. And so for C, I'm going to count over 2, 1, 2, up 3, 1, 2, 3, And now I'm going to reverse it. I'm going to count along the x-axis 3 units, 1, 2, 3. But now along the y-axis, a negative 2 units, 1, 2. Now with some practice, a little bit hard, and with some practice, you'll understand it, you'll see it. But it's a way to check what you're doing. There's a couple ways to get there as you do these. All right, so this one. This is problem number 5, the last problem. Actually, you're supposed to reflect A to B, so using only reflections. And I originally thought that the reflection was this way, that this was the line of reflection, and so this point can go to here, and this point can go to here. Remember, you're going to draw perpendicular lines, lines at right angles. But if you do that, this point would end up here. It doesn't land here. It doesn't map to that point. It maps to here. And this point would end up here. It's not landing here. So it's not a reflection over this line of reflection. It's two reflections. Actually going to reflect it over the x-axis. So this quadrilateral is going to reflect over the x-axis and end up here. And then that's going to reflect over the y-axis and end up where B is. So it's a reflection over the x-axis and then a reflection over the y-axis. And that's it. We could talk about the coordinates for reflections. Remember that the coordinates remain in the same order, just one of them switches signs. And so if we were to look at that quickly in this case, just one example, let's look at this point right here. It reflects over the x-axis, so the x value remains the same, -1, and this is +3, but then the reflection switches signs. It's like just changing, turning the opposite direction and going to a -3. So the coordinates remain in the same order, it's just one of them switches signs.